rapid advancement of technology, transmitting data from satellites has become more critical than ever before. While many are familiar with Starlink's satellite network, China is quietly revolutionizing the field with a new satellite technology that achieves data transmission speeds 5 times faster than its competitor. What makes this technology so remarkable? Could China be ushering in a new era for telecommunications and global connectivity? Join Top 10 Discoveries Official as we dive into the story of AO-MDR technology and how China is rising to the forefront of satellite data transmission innovation. Satellites play an indispensable role in connecting global telecommunication systems, transmitting information, images, and data in real time. Over the past few decades, satellite systems have evolved continuously, from television and telecommunications satellites to those serving military and scientific purposes. With technological advancements, the demand for faster data transmission speeds has grown, requiring new technologies to meet the needs for speed, stability, and cost-effectiveness. While other nations continue to deploy low Earth orbit (LEO) satellite networks, such as SpaceX's Starlink, China has achieved a groundbreaking advancement with satellite data transmission technology using low-power lasers. Specifically, China has successfully transmitted data from a geostationary orbit (GEO) satellite, located approximately 22,369 miles from Earth, at a speed of 1 gigabit per second, 5 times faster than current satellite systems like Starlink. This milestone opens a new chapter for space data transmission technology, particularly as the global demand for high-speed, stable internet connectivity continues to rise. Geostationary orbit (GEO) satellites operate in an orbit around Earth at an altitude of about 22,369 miles. At this altitude, a satellite can maintain a fixed position relative to Earth's surface, enabling stable connections with ground-based receivers. While LEO satellites are widely used due to their low latency, GEO satellites offer advantages in broader coverage and stability. However, the primary challenge with GEO satellites has been higher latency due to their significant distance from Earth. China has effectively addressed this challenge with its satellite data transmission technology using lasers. Instead of relying on traditional radio waves, China has deployed a laser system with a power output of 2 watts, delivering exceptional efficiency and transmitting data at a speed of 1 gigabit per second. Compared to conventional data transmission technologies, this laser-based system not only reduces latency, but also enhances the quality of data transmission. Despite the laser system's modest 2-watt power, it enables the transfer of vast amounts of data over extremely long distances, achieving speeds 5 times faster than Starlink. China's achievement is not merely a significant technological milestone, but also a bold statement of its leadership in the global space technology race. China's laser-based satellite technology could serve as a critical foundation for future global telecommunications and internet networks, particularly for regions that are difficult to reach with traditional transmission methods. Satellite laser data transmission operates on the principle of using light to encode and send signals through space. Unlike radio waves, which are used in systems like Starlink, lasers offer greater bandwidth, lower latency, and superior security. A single laser beam can carry several gigabits of data per second, compared to just a few megabits per second for radio waves, unlocking the potential for high-speed connections. From streaming 4K video to transmitting complex scientific data. However, this technology faces a significant challenge: atmospheric turbulence. As laser beams travel through Earth's atmosphere, turbulent air currents scatter the light, causing signal distortion and weakening. At distances exceeding 22,800 miles from geostationary orbit, this issue becomes particularly severe, potentially reducing signal strength by up to 70% without effective solutions. In contrast, Starlink operates in low Earth orbit, at approximately 340 miles, to minimize interference, making geostationary satellites face far harsher conditions. The United States has also experimented with laser data transmission through NASA's Psyche project, achieving a speed of 25 megabits per second over a distance of 140 million miles in the year 2024. While impressive in terms of distance, this speed remains lower than China's achievement in geostationary orbit. Limitations caused by atmospheric interference make it difficult for current laser systems to maintain consistent performance, especially at high altitudes. China has found a way to overcome this barrier, creating a revolutionary breakthrough in harnessing the potential of satellite laser technology. The AO-MDR technology, standing for Adaptive Optics, AO and Multimode Diversity Reception MDR, represents a groundbreaking advancement in satellite laser communication. Positioning China as a leader in data transmission from geostationary orbit, this system is designed to overcome atmospheric turbulence, a major barrier that distorts and weakens laser signals over tens of thousands of miles. With a laser power of only 2 watts, equivalent to a nightlight bulb, AO-MDR achieves a data transmission speed of 1 gigabit per second, a technical feat that not only surpasses existing systems, but also unlocks potential for future communication applications. Adaptive optics is a technology already used in fields like astronomy and telecommunications, with the primary goal of improving the quality of light signals transmitted through turbulent environments. In Earth's atmosphere, light waves are disrupted by factors such as wind, temperature, and humidity. These disturbances can blur or degrade the accuracy of light signals. To address this, adaptive optics employs ultra-precise micromirrors to reshape distorted signals. In China's case, the system uses 357 micromirrors within a telescope with a diameter of 1.8 meters to adjust the laser beam, ensuring the precision and stability needed for data transmission. This is particularly critical for transmissions from geostationary orbit satellites, where signals must travel vast distances and face significant atmospheric interference. By leveraging adaptive optics technology, China can maintain signal quality and optimize data transmission in the challenging space environment. As signals travel through space and the atmosphere, light beams can scatter and weaken, making them difficult to receive. To counter this, China has implemented Multimode Diversity Reception MDR technology, which splits the light signal into multiple channels and selects the strongest ones for recombination. The MDR system divides the signal into 8 distinct channels and employs an optimal path selection algorithm to combine the 3 strongest channels, enhancing signal quality and stability. The MDR system not only improves signal reception, but also minimizes error rates, a common issue in traditional satellite systems. By separating and selecting the strongest signals from multiple channels, this technology ensures efficient data transmission, even when environmental factors like atmospheric turbulence or long distances weaken the signal. The combination of these 2 technologies creates an exceptionally robust satellite data transmission system. Adaptive optics optimizes signal quality from the moment it is emitted from the satellite, while MDR ensures that strong, stable signals are received efficiently. Together, AO and MDR deliver a system that is not only high speed, but also remarkably stable and accurate. In China's case, this system has boosted the usable signal reception rate from 72% to 91.1%, while significantly reducing error rates, thereby enhancing the efficiency of data transmission. This combination is not merely a technical advancement, but also paves the way for future satellite data transmission systems. With this technology, China not only meets the demands for speed and stability, but also masters a technology with wide-ranging applications in critical fields, from telecommunications to defense. This system, with its ability to deliver stable and rapid data transmission over vast distances, is laying the foundation for the robust development of high-speed internet services in the future. Compared to efforts in the United States, AO-MDR represents a clear leap forward. Projects at NASA and MIT often use adaptive optics or multimode diversity reception individually, but they have not integrated both as effectively as China has. For instance, NASA's T-Bird system achieved a speed of 200 gigabits per second in the year 2023, but it operated from low Earth orbit, approximately 340 miles from Earth, where atmospheric interference is less severe. In contrast, AO-MDR maintains stable performance in geostationary orbit, where conditions are far more challenging. Starlink, relying on radio wave technology, cannot compete in terms of speed or technical complexity, as it is limited to a few megabits per second. The development of AO-MDR also reflects China's persistent research efforts, led by experts from the Beijing University of Posts and Telecommunications and the Chinese Academy of Sciences. This technology is the result of years of experimentation and optimization. Beyond improving signal quality, AO-MDR reduces operational costs by using low-power lasers, enabling large-scale deployment. With the advent of AO-MDR technology, China has solidified its position in the field of space technology and opened significant opportunities for the development of high-speed satellite data transmission systems in the future. China's satellite technology extends beyond improving data transmission speed and stability, reaching into critical applications. Particularly in military and space security domains, one of the most notable features is the enhanced security and safety of this satellite data transmission system, which could fundamentally transform how nations protect information and maintain communication during emergency situations. Amid intensifying competition in space and growing threats from international forces, maintaining a secure satellite data transmission system has become a critical priority for nations. China, with its advanced laser satellite technology, can provide a secure and stable data transmission channel that is difficult to jam or intercept, which is vital in military scenarios. China's satellite data transmission channels not only ensure the secure transfer of information between government agencies and military forces, but also enhance coordination among military units during operations and defense missions. While data transmission systems relying on radio waves are susceptible to external factors such as signal interference, laser-based technology offers transmission capabilities that are far less affected by environmental conditions. This enables China's satellite system to maintain stable and secure connections during emergencies, when traditional communication systems may be disrupted or targeted. Laser satellite technology could serve as a strategic tool in military operations, not only for transmitting information, but also for controlling military equipment and conducting remote surveillance missions. A prominent example is China's Shenzhen-20 satellite. In the year 2020, this satellite not only achieved a laser data transmission speed of 10 gigabits per second, but also demonstrated its ability to protect information by successfully evading a United States reconnaissance satellite. This flexibility highlights the potential of laser technology in maintaining data security, particularly in sensitive communication systems, intelligence applications. Satellites with stable and high-speed data transmission capabilities are not only valuable in military operations, but also in intelligence activities. China can leverage this technology to collect and analyze intelligence data from Earth-observing satellites, particularly for surveillance and forecasting strategies. The data obtained from these satellites enables China to monitor critical regions worldwide, track the military and political activities of rival nations, and make timely strategic decisions. With rapid and stable data transmission speeds, China can deploy advanced intelligence satellite systems to transfer large volumes of data without interruptions, thanks to its ability to transmit data reliably and quickly over long distances. This technology can significantly support defense and intelligence operations, contributing to national security protection. By developing and applying this technology, China is solidifying its position in the global space technology competition. China's satellite technology not only delivers remarkable advancements in data transmission, but also expands its potential applications across various fields, particularly in telecommunications and information technology. These breakthroughs could transform global connectivity, enhance the quality of internet services, and create numerous opportunities for cutting-edge technological applications. 5G and 6G telecommunications. One of the most promising applications of laser satellite technology lies in supporting the global deployment of 5th-generation and 6th-generation networks. High-speed data transmission satellite systems can complement existing network infrastructure, particularly in hard-to-reach areas where building traditional telecommunications infrastructure, such as fiber optic cables and base stations, is not feasible. Satellite technology can deliver high-speed internet services to remote regions, far-flung islands, and isolated areas where conventional transmission methods face significant limitations. With the development of 5th-generation networks and the future of 6th-generation networks, the demand for higher speeds and greater bandwidth continues to grow. While terrestrial telecommunications networks may struggle to provide high-speed services in geographically challenging areas, satellites can play a crucial role in expanding global connectivity. China's laser satellite technology, capable of transmitting data at speeds up to 1 gigabit per second, is well equipped to meet these demands, offering an efficient solution for deploying 5th-generation and 6th-generation network services with low latency and stable transmission speeds. Cloud services and online conferencing. In the context of global pandemics and the growing trend of remote work, the demand for cloud services and online conferencing has become essential for businesses and organizations worldwide. High-speed data transmission satellite technology can enhance the quality of these services, delivering a smoother experience for users. Particularly in online meetings, the transmission of video and large volumes of data requires high speed and excellent stability. With its ability to provide stable and rapid services, satellite technology can play a vital role in maintaining connectivity among remote work teams, minimizing disruptions during information exchanges. Furthermore, this technology can enable companies to transition to virtual work environments more efficiently, without concerns about signal shortages or weak connections, which are common issues with terrestrial communication networks in remote areas. Global IT infrastructure. With the rapid growth of information technology services and applications, the demand for stable and high-speed network connectivity is a critical factor in sustaining the development of digital economies. China's satellite technology can contribute to building a more robust global telecommunications infrastructure, particularly in facilitating data transmission across national and regional boundaries. This satellite system can support connectivity between global information systems, enhance data exchange between data centers, and lay the foundation for cloud technology services. Moreover, these satellite technologies can reduce reliance on terrestrial telecommunications infrastructure, offering benefits not only in maintaining stable connectivity, but also in minimizing the costs associated with network maintenance and upgrades. Geostationary orbit satellite systems equipped with laser technology not only improve service quality, but also create new opportunities for telecommunications providers and technology companies to develop innovative products and services. China's satellite technology holds immense potential for advancing high-tech applications in telecommunications, cloud computing, and global network infrastructure. By delivering high-speed internet services to hard-to-reach areas and enhancing the quality of online conferencing and cloud services, this technology opens opportunities for nations and organizations to optimize connectivity and boost operational efficiency. China is steadily establishing its leadership in developing cutting-edge technologies, making significant contributions to the future of global information technology infrastructure. China's satellite laser data transmission technology, with its adaptive optics and multimode diversity reception system, represents not only a technical breakthrough, but also a foundation for a new era of space communication. Achieving a speed of 1 gigabit per second from geostationary orbit, more than 22,800 miles from Earth, using a laser with only 2 watts of power, China has demonstrated its ability to overcome seemingly impossible limitations. This achievement, built upon previous records, underscores its ambition to shape the future of global connectivity. The adaptive optics and multimode diversity reception system opens a long-term vision where laser-based satellite networks become the backbone of next-generation communication infrastructure. With a usable signal retention rate of 91.1%, this technology lays the groundwork for 6th-generation networks, promising speeds in the range of multiple gigabits and latency below 1 millisecond, far surpassing current 5th-generation networks. Furthermore, China is moving toward integrating laser technology with cutting-edge fields like quantum communication, which can encode data at the atomic level, offering unprecedented levels of security. These advancements not only solidify China's leadership, but also redefine how the world connects, from major cities to the most remote regions. Compared to the United States, where projects like NASA's TB-EARD achieved a speed of 200 gigabits per second from a low Earth orbit of 340 miles in the year 2023, China stands out for its efficient operation in geostationary orbit. While America's Starlink focuses on providing civilian internet with speeds of a few megabits per second, China's laser technology demonstrates superior potential in building integrated global networks, spanning civilian communications to high-security applications. The distinction lies in the integrated nature of the adaptive optics and multimode diversity reception system, a solution that American systems have yet to achieve at the same altitude and complexity. The future of space communication is being shaped by innovations like adaptive optics and multimode diversity reception. China is not stopping at its current satellites, but is aiming for a global network of hundreds of laser-equipped satellites, connecting every corner of the planet. With its current pace and innovation, China is painting an ambitious picture where space becomes the foundation for a new generation of global connectivity. As the world enters an era where global connectivity increasingly defines how we live and work, China's satellite laser data transmission technology emerges as a game changer. This system not only showcases technical prowess, but also reflects a long-term strategy to lead space communication infrastructure. A deeper analysis reveals that this technology demonstrates an integrated approach, balancing technical innovation with economic efficiency. Compared to the United States, where projects like NASA's T-Bird operate in low Earth orbit at 340 miles, China displays a clear advantage in tackling more complex technical challenges in geostationary orbit, which demands greater precision and resilience. The impact of this technology extends far beyond its technical aspects, influencing economic and social domains. By utilizing energy-efficient laser systems, China lays the foundation for deploying large-scale satellite networks at low cost, creating connectivity opportunities for regions lacking terrestrial infrastructure. This not only drives economic growth, but also fosters a more sustainable communication model. What are your thoughts on this? Can other nations, including the United States, develop similar solutions to remain competitive in this space race? With its current pace of innovation, is China painting a future where space becomes the centerpiece of global connectivity, reaffirming the role of satellite technology in the 21st century? Share your thoughts in the comments below. Don't forget to hit subscribe to stay updated on the latest insights into technology, national strategies, and groundbreaking inventions shaping the future. Top 10 Discoveries Official will be back with untold stories, projects that push boundaries, and quiet revolutions with global impact. See you in the next video.